light of the recent NASA announcement, where flowing water was officially found on Mars, I've decided to discuss water and why we care about it so much. Because we care about it a lot, so much so that any measurable property that relates to water in any way often uses water as the baseline. For example, a gram was originally defined as the mass of 1 cubic centimeter of water, and, correspondingly, water has a density of almost 1 gram per cubic centimeter. Our measurements became more accurate since the density scale was first introduced. Pure water freezes at 0 degrees and boils at 100 degrees. The pH scale, which measures acidity, uses water as its neutral point at a pH of 7. Altitude measurements start at sea level, so we determine height based on where water is positioned. Water has a viscosity, which measures how well fluid flows, of 1 centipoise, with a centipoise being the standard unit of measurement for viscosity, and is equivalent to 1 millinewton second per meter squared. Furthermore, the specific heat of water, which is a measure of how much energy it takes to heat up a given amount of something by 1 degree, has a value of 1 calorie per gram degree Celsius, which is actually quite high. Admittedly, specific heat is more commonly measured in joules per gram degree Celsius, in which case water does not have a value of 1, but that's aside from the point. There are no doubt more examples of these for water, but I think you get the point. Of course, this brings up the question, why do we care so much about water? Well, the simple answer to that is because we need it to live. But why? For a multitude of reasons, really. For one, water is really good at dissolving things, such as salt, so, among other things, this makes it ideal for use by our kidneys to remove waste. It can also absorb a lot of energy, due to its high specific heat. So, as we sweat, the water in said sweat absorbs the heat from our bodies, evaporating and cooling us down. Also, being a liquid, things can float around in it easily. This makes it an ideal basis for blood, as well as the cytoplasm inside cells, where various cell components, more commonly called organelles, need to float around. Of course, what is the basis for all of our bodily functions have to be water? Well, it's likely because the single cells we evolved from were based on water, and they in turn were based on water because that was, and still is, the predominant liquid on Earth. As I mentioned, things move around easier in liquids, so chemical reactions happen a lot faster in liquids. As such, amino acids could thus join together in water and form basic proteins, which then led to the creation of DNA, which in turn has allowed for the extended chemical reaction that is life. So, in fewer words, we rely on water because it allows chemical reactions to take place. There is, of course, more to water's importance than just being a liquid. It is also polar. This means that the electrons surrounding the water molecule tend to spend more time around certain parts of the molecule. In the case of water, which is made of 2 parts hydrogen and 1 part oxygen, the electrons tend to spend more time around the oxygen. Now, while water has an overall neutral charge, the electrons hanging around oxygen create a more negative charge on that end, while the hydrogens have a correspondingly positive charge. This polar nature causes water molecules to orient themselves so that the hydrogen of one molecule is near the oxygen of another. The physics of this is due to the electromagnetic force, where the positive hydrogen is attracted to the negative oxygen. When water orients itself like this, it forms what is known as a hydrogen bond. These hydrogen bonds are actually the source of surface tension, also called cohesion, where water may overflow a glass slightly, but won't spill because the water sticks to itself. The hydrogen bonds are strong enough that this cohesion can actually support lightweight objects such as a paperclip. Furthermore, water can hydrogen bond to other polar objects, which is referred to as adhesion. This is the source of what is called capillary action, where water can actually flow up a pipe on its own, given that the tube is small enough, like blood vessel small. Aside from forming the meniscus, which you may remember from chemistry labs when using a graduated cylinder, capillary action is what brings up water from the ground to the leaves where it's needed in plants. Adhesion is also what makes water so good at dissolving things. Ionic compounds, which are formed from a metal and a non-metal, table salt being a good example, are polar. However, instead of electrons just spending more time around the non-metal actually just absorbs an electron donated from the metal. Nevertheless, water, being polar, aligns itself with the ionic bond and forms hydrogen bonds with the non-metal. As mentioned, these hydrogen bonds are fairly strong. So strong, in fact, that water rips apart the ionic bond, just leaving the metal and non-metal ions, which then spread evenly throughout the water. We refer to this entire process as dissolving. Hydrogen bonds are strong enough to overpower pretty much any ionic bond, which is why water is such a fantastic solvent. Aside from ionic compounds, water is also able to dissolve just ions on their own, an ion being a charged atom or molecule. In fact, water is able to dissolve pretty much anything with a charge distribution. Water cannot, however, dissolve nonpolar molecules, where the charge is evenly spread throughout the entire molecule. This is because water has no place to align with something that's nonpolar, so it can't hydrogen bond with it, and thus it can't rip it apart. Although this feature also makes water really useful for life. Nearly all organic compounds are nonpolar, so we can't dissolve in water. In fact, cell membranes, which protect a cell from the outside world, are predicated on the fact that they don't dissolve in water. This lack of dissolving actually repels water, and thus pretty much anything else that wants to get inside a cell that we don't want inside our cells. Hydrogen bonds give water other interesting properties. Since hydrogen bonds form naturally from the electromagnetic force, it takes energy to break them. This is actually why water has such a high specific heat. A lot of the energy pumped into water, when trying to heat it up, is used in breaking hydrogen bonds. This of course means that water can absorb a lot of energy, making it a very good thermal regulator. As such, coastal areas don't experience as extreme temperature changes as areas farther inland do. This is quite useful for life, as there are definite limits to how hot or cold an organism can be and stay alive. Additionally, hydrogen bonds form a bit of a structure within water. There is a sweet spot for how far apart a hydrogen wants to be from an oxygen when forming a hydrogen bond. As such, hydrogen bonds put the molecules of water at set distances from each other, so the number of hydrogen bonds affects how dense water is. Ice doesn't form as many hydrogen bonds, so when solid, the water molecules tend to spread out a bit. This is compared to cold water, specifically at 4 degrees Celsius, where water forms its maximum number of hydrogen bonds, thus making water densest at this temperature. This is why ice floats on water. Hydrogen bonds make the water denser. This, of course, has benefits to life, as water freezes from top down. This means that the layer of ice forms an insulating layer from the cold atmosphere, and thus prevents heat from leaving the further down water. Therefore, aquatic life can spend its time floating in the water, protected by the ice, and not die from freezing. As you are likely already aware, water is quite important to us. It is a liquid and dissolves things easily, allowing chemical reactions, including those that sustain life, to easily take place. It regulates temperatures and protects aquatic life from freezing. Also, it can bond with itself and other things, forming the neat, and useful, features of surface tension and capillary action. All of this is based off of the fact that electrons tend to spend more time around oxygen than hydrogen, making water polar. Nevertheless, hope you enjoyed it, hope you learned something, and see ya.